Hi, welcome to the demo. In the next 5 minutes, we're going to be walking through the diagram that you're seeing on the bottom left of my screen. So to get started, let's first check that our code is running on an authentic Azure Confidential VM. And as you can see from this property, it shows that the VM is running on AMD 7SMP chip. And similarly, when we go to the Azure portal, we're actually able to see that the VM is running on a DC2 SKU as well. And for our Azure SQL database, we can see that it's running on a DC SKU machine as well. So going back into our diagram, essentially what we're going to be showing here is a sample HR web application that you can see on the top left of my screen. And it's running essentially on ASP.NET. And so one thing I do want to call out is that we basically lift and shifted this code from an existing repository, and we had to make no code level changes in order to have this application running on a confidential VM. And so what I'm basically doing in this bit here from line 85 is I'm intercepting the query strings that are being passed in from the application. And the idea is we're basically going to be streaming this to Azure Confidential Ledger. And so to show you that, so essentially, I'm basically playing the role of a curious HR admin. So the idea is I am a authenticated user in this application, but as an organization, you might want to have end-to-end visibility, not only with who has access to your application, but with regards to what kind of sensitive information they're pulling as well. And so what you can see here is in this application, I can, for example, go ahead and perform some filters. I might want to pass in the name of a certain person and do some query and some filtering on that as well. And so that brings us to this right-hand side. And what we're essentially doing here, as you can see, is we're getting the real-time log information that this web app is generating, and I'm basically streaming it into Azure Confidential Ledger. So let me just show you the code that I have here that basically does this. Is very simple. So first off, basically what we're doing is we're pulling some packages from PyPy for Azure Confidential Ledger, and we are essentially pointing it to the location of the logs. We're instantiating the identity services client, and at that point what I'm doing is essentially getting a network identity object that is pointed to my unique ledger ID, and I am writing the PEM certificate that is being generated on the fly just as a print statement here, as you can see. And from then on, I am basically authenticating to the confidential ledger using Azure Active Directory service principals, as you can see here, getting the credential object, getting the ledger client object, and at this point I have everything I need to essentially interact with the ledger. So here on line 41, I basically have a very simple infinite loop, and essentially what it's doing is for each line in the log that is being generated, I am essentially appending each of those entries into the ledger. And the reason this is very important is because Azure Confidential Ledger, it is an append-only log, so we cannot, for example, go ahead and make changes to any pre-existing entry. Essentially, it's using blockchain technology at the back end in order to enforce that condition. But essentially, once the commit is performed and I have the transaction ID back for the log entry, essentially what I'm doing here is I am getting that same entry back using the transaction ID, and I'm printing it as a print statement here. And essentially that completes the loop that we looked at over here into our console app. So essentially we have written all of our sensitive logs, and we've also got the ability to read that log back in a secured manner. So what is the next step? Essentially, we have shown how a web application can be protected with Azure Confidential Ledger, but that doesn't show us how a database admin who might have full DB owner access to your database might not be able to see your sensitive data. So for example, on the right here, what I'm doing is I'm logged into SSMS with the DB owner for this database. And what you can see here is even though I've got DB owner access, since I don't have access to the column master keys, which are being stored in Azure Key Vault mHSM, I cannot go ahead and decrypt those sensitive columns, while at the same time, my web application can transparently get all of the information back in an unencrypted manner. And the reason it's being able to do that is because of the SQL driver that it's using to abstract all of that away. And so one of the things that I can do as a database owner, as a database admin, is essentially I can go ahead and initiate a extended event session. So let me go ahead and initiate a new one here. And what you'll see is that all the queries that get made as part of my database will get captured. So for example, if I go ahead and perform a couple queries and I pass in a predicate and I refresh this, what you'll see is that those 3 queries that I just made are getting captured. But the real cool part is basically this. Even though my database query is being passed in with the predicate filters, as you can see here, that information is not available to me as a DB owner or a DBA. And so essentially this information is encrypted, but that doesn't take away from the ability of the web app to run rich confidential queries, as you can see here. So for example, I'm doing a search pattern. We are going ahead and doing a filter. We had some range conditions that are being passed in. And so the web app can fully run in a secured manner within an Azure Confidential VM without any changes to the code, while your data as well as your sensitive logs are being protected thanks to Azure SQL, always encrypted with secure enclaves. So I hope you found this demo useful, and let me know if you have any questions. All of the code will be pasted on GitHub, and until next time.